Okay, today I am going to present my homework 3 for CPSC 5260, Introduction to Parallel Algorithm. In this assignment, I have actually extended the multi-thread prime number generator from homework 2 by adding critical thread synchronization mechanism. The main objective were implementing mutex protection for shared data, using condition variable for efficient thread coordinations, and collecting exactly 20 random prime numbers. And additionally, I will demonstrate the strong scaling analysis by testing with different thread counts like 50 or 1000, 100. And now let's walk through the code structure. So it's a C-based code. So first, our configuration that the number of thread is I fixed at 100, and eventually I will show the for the 50 and thousands number of threads. So and the number values, which is actually 20, the total number of random primes to generate, and the maximum tries, actually the maximum attempts for each thread, it's number 10. So and this needs reasonable time to execute this program. The thread result is structure actually stores the prime number found by each thread in a global array and counter for found prime numbers. And now for this critical shared data, the primes array holds the 20 prime numbers founded by this program, and the prime count variable actually tracks how many actually collected so far. And here's the mutex and the conditional variable. The mutex acts as a lock to prevent race conditions when multiple threads try to access shared data simultaneously, and condition variable allows threads to efficiently signal when they have reached the goal. And the is prime actually function determines if a number is prime using an optimized brute force algorithm, and number less than or equal to 1 are not prime, 2 and 3 are prime. We skip even numbers and multiples of 3. Then we test divisors from 6k plus or minus 1 up to square root of number. The optimization significantly reduces the number of checks we need to perform, and making the algorithm much faster than testing every possible divisor. Okay, so there is a magic happens when the generate prime function that each thread executes. First, notice this the line. We create a thread safe random seed by combining the current time and thread ID using OR, and this ensures each thread has its own unique random number generator, preventing race conditions that could occur with the standard random function. Each thread tries up to maximum tries times to find the prime number, and we use and now the critical section, the most important part. When the thread finds a prime, it must log the mutex before accessing shared data. This lock prevents other threads from accessing the primes array and counter simultaneously. We check if we still needs more primes. If yes, then add our prime to the array. increment the counter and print the result. And if we are just reach exactly 20 primes, we broadcast a signal that condition variable to wake up and waiting main thread. Finally, we unlock the mutex to let the thread proceed. Then the thread exits since it found its prime. If a thread exhausts all its attempts without finding a prime, it simply exits. And in the main function, we seed the random number generators and start our timer. Then we create all 100 threads. Each thread starts executing the generate prime function independently. This is crucial. The main thread locks the mutex, then waits on the condition variable. This puts the main thread to sleep until a worker threads signal that 20 primes have been found. This is much more efficient than continuously checking the counter in a loop. So once we get finally we print all the prime number we found, display the total count, show the execution time, report how many threads we used, and clean up our synchronization primitives. So now I'm going to run this code for number of thread is 100. So to do this, I need to first compile this code, and to compile I use this GCC, also the val and 03 for warning. So if there is warning, it will show. There is no warning, so we are going to run this code for 100 threads. So it's found the 20 prime numbers. Also, its total time taken is 0.01 second, and the number of thread used is 100. So now I'm going